Imagine standing on the brink of existence, where the vast cosmos stretches infinitely into a dark, unknowable expanse. Here, at the edge of the universe, the very fabric of reality seems to tremble with possibilities. What lies beyond this point, where the known laws of physics may falter? Is it a boundless void, a mirror universe, or something far stranger? Picture the universe as an ocean, its waves silently lapping against the shores of a mysterious land yet to be charted. As we peer into this abyss, we confront not just a scientific enigma, but a profound philosophical question that has intrigued humanity for centuries. What exists outside the edge of the universe? The journey begins in the early 20th century, amidst the golden age of cosmology. Edwin Hubble, with his pioneering observations, expanded our understanding of the universe. In 1929, he discovered the universe was not static but expanding, a realization that shattered previous conceptions. This expansion hinted at the universe having an origin, a beginning that suggested an edge. Hubble's work, combined with Einstein's theories of relativity, laid the groundwork for modern cosmology. But the question lingered: if the universe is expanding, what lies beyond its ever-stretching boundary? The notion of an edge to the universe defies our understanding of infinity. How can something infinite have an edge? This paradox challenges the very principles of mathematics and physics. The universe, as a boundless expanse, seems to contradict the idea of a physical boundary. This contradiction has puzzled scientists, forcing them to reconcile with the possibility that our universe might be just one of many, or that it curves back onto itself in ways we cannot yet comprehend. As telescopes advanced, astronomers began to gather more data, peering further into the depths of space. Instruments like the Hubble Space Telescope allowed us to observe galaxies billions of light-years away. Yet, despite our technological prowess, the edge of the universe remains elusive. Cosmic microwave background radiation, the afterglow of the Big Bang, maps the visible universe, but what lies beyond this observable boundary? Each discovery only deepens the mystery, revealing a universe more complex and enigmatic than we ever imagined. The mystery intensifies as scientists consider the implications of dark energy, a force driving the accelerated expansion of the universe. This acceleration suggests not just an expanding universe, but one that is stretching faster over time. Could this mean the universe will expand endlessly, or might it eventually tear apart in a big rip? Such possibilities challenge our understanding and hint at unknown realms beyond our cosmic horizon. Leading theories attempt to explain this cosmic puzzle. The multiverse hypothesis suggests our universe is one of many, each with its own laws of physics. Quantum fields and string theory propose additional dimensions, potentially offering pathways to other universes. Meanwhile, the concept of cosmic inflation posits an exponential expansion of space in the early universe, possibly creating bubbles of universes within a larger multiverse framework. Each theory offers a glimpse into what could lie beyond, yet none provide definitive answers. To explore these possibilities, scientists employ advanced tools and missions. The James Webb Space Telescope promises to look further back in time, potentially observing the earliest galaxies and providing clues about the universe's beginnings. Particle colliders like the Large Hadron Collider explore fundamental particles, seeking to understand forces that could reveal new dimensions. These efforts represent humanity's quest to grasp the universe's ultimate nature. As we ponder the edge of the universe, we confront profound questions about our place in the cosmos. Does the universe's vastness render us insignificant, or does it elevate the human spirit, urging us to explore the unknown? This mystery challenges us to rethink our understanding of reality, time, and space. While we may never fully comprehend what lies beyond, the pursuit of knowledge drives us forward, igniting a sense of wonder and curiosity that defines the human experience. The universe, in all its mystery, invites us to dream, explore, and discover the uncharted territories of our imagination. Imagine a vast cosmic stage where every star, galaxy, and nebula plays its part in a grand ballet. You're not just a spectator, you're right there on the edge of the universe, peering into the unknown. This is where Edwin Hubble's groundbreaking discovery comes into play, a revelation that forever changed how we see the cosmos. In the 1920s, Edwin Hubble was peeking through the Mount Wilson Observatory's giant telescope in California. What he saw was astonishing. Galaxies weren't just distant, floating islands in the dark, they were moving away from us. The universe wasn't static. It was expanding. This discovery was like finding out the universe had a heartbeat, a rhythm that pulsed outward into infinity. Why does this matter to you? Well, Imagine the universe not as a fixed stage, but as an ever-expanding balloon. As it grows, questions arise. What happens at the edge of this balloon? And what exists beyond it? This realization sparked a new era, leading us into the age of space exploration and cosmological theories that stretch the limits of human imagination. Now, let's dive into how Hubble's discovery has led us to the concept of the universe's expanding edge. The more we understand this edge, the more we realize it's not a boundary in the traditional sense. It's a frontier, one that challenges everything we know about time, space, and even reality itself. Picture the cosmos as a grand tapestry. Each thread is a galaxy, and with time, this tapestry stretches. Hubble's findings were like discovering the loom. He wasn't just looking at stars, he was watching the universe breathe. But what lies beyond this expanding edge? Is it more universe, or something entirely different? This question is like looking at the ocean and wondering what's below the horizon. It's a mystery that compels you to keep looking, keep questioning. Hubble's observations were just the beginning. They opened the door to new questions and theories about the universe's structure and fate. What if beyond our universe lies another, with its own galaxies and stars? Or perhaps there's a multiverse, a collection of universes, each with different laws of physics. These ideas aren't just the stuff of science fiction. They're serious scientific inquiries, driven by the desire to understand the true nature of our universe. And you, as a curious mind, are part of this journey. Your imagination fuels the exploration of these cosmic frontiers. Consider this: as the universe expands, it's not just galaxies moving further apart. Space itself is stretching. This means that the very fabric of reality is in motion. So, what does this mean for the edge of the universe? If space is expanding, can there even be an edge in the traditional sense? This is where things get a little tricky. Our usual understanding of edges and boundaries doesn't quite apply. Instead, the edge of the universe is more like a conceptual limit, one that's constantly moving. It's a bit like chasing a horizon that keeps retreating as you move forward. And this leads us to a crucial point: the universe's expansion isn't slowing down. In fact, it's accelerating. This mysterious force, known as dark energy, is pushing the universe to expand faster and faster. But what exactly is dark energy? And why is it causing the universe to speed up? Imagine a race car gaining speed without any visible driver. That's what scientists see when they look at the universe's accelerating expansion. Dark energy is the invisible hand on the throttle, and understanding it could unlock new insights into the cosmos. But here's the kicker: we barely know what dark energy is. It makes up about 68% of the universe, yet it remains one of the greatest enigmas in modern physics. This is a classic case of the more we know, the less we understand. So, what does this mean for the edge of the universe? If dark energy continues to drive expansion, the edge keeps moving, slipping further into the unknown. It's like trying to catch a wave that's always just out of reach. This mystery deepens when we consider the implications of an ever-expanding universe. If the universe expands forever, will galaxies eventually drift so far apart that their light no longer reaches us? It's a chilling thought: an isolated universe, where stars fade into darkness, and the cosmos becomes a cold, empty place. But let's not get too gloomy. Remember, every question we uncover is a step forward in our understanding. With each new discovery, we peel back another layer of the cosmic onion, revealing the intricate beauty of our universe. And while we may not have all the answers yet, the journey itself is a testament to human curiosity and resilience. We are explorers at heart, driven by the desire to understand the universe and our place within it. As we stand on the brink of the universe, peering into the unknown, remember that this quest is far from over. The edge of the universe is not just a boundary, it's an invitation. An invitation to explore, to discover, and to dream of what lies beyond. So, what do you think exists at the edge of the universe? Is it more stars and galaxies, or something entirely beyond our comprehension? As we continue this cosmic journey, one thing is certain: the universe is full of surprises, and its mysteries are just waiting to be unraveled. Stay curious, keep exploring, and who knows? Maybe one day, you'll be the one to uncover the secrets of the universe's expanding edge. Until then, let the wonders of the cosmos fuel your imagination and drive your thirst for knowledge. Imagine a universe so vast that it stretches beyond the limits of human comprehension. It's a place where the very notion of an edge becomes a source of deep mystery and intrigue. As you delve into this cosmic enigma, you're not just peering into the depths of space but into the very essence of what it means to exist. What lies beyond the boundary of the universe? Is there even a boundary at all? These questions lead us into the heart of a profound scientific dilemma known as the horizon problem. To truly grasp the magnitude of this problem, let's start with the basics. Picture the universe as a balloon. As it expands, the surface grows, but there's no discernible edge. This analogy serves as a simplistic model for the universe's expansion. The horizon problem arises from the observation that different regions of the universe, now separated by vast distances, appear remarkably similar in temperature and structure. This uniformity is puzzling because, according to the laws of physics, these regions haven't had enough time to influence each other since the Big Bang. This scientific conundrum has sparked intense debate among cosmologists. One provocative solution is the theory of cosmic inflation, proposed by physicist Alan Guth in the early 1980s. Imagine the universe ballooning exponentially just after the Big Bang, ironing out any initial irregularities. This rapid expansion could explain the observed uniformity, setting the stage for the universe as we know it. But here's what most people don't know. The horizon problem also opens the door to the tantalizing possibility of a multiverse. If inflation can occur once, why not multiple times, spawning countless bubble universes? Each of these bubbles could have its own laws of physics, dimensions, and even fundamental constants. It's a mind-bending idea that challenges our understanding of reality itself. Yet, some scientists argue that the universe might be finite, with no edge at all. This perspective suggests that the universe is a closed, self-contained entity. In this model, what appears as an edge is simply a limitation of our current observational capabilities. The universe could be curved in such a way that traveling in one direction would eventually bring you back to your starting point, much like circumnavigating the globe. Let's explore this concept with a real-world analogy. Imagine standing on a vast Earth-like planet with no landmarks. As you walk in a straight line, you wouldn't encounter an edge. Instead, you'd eventually return to your original location. Similarly, our universe might be a closed loop, with no true boundary. But how can we know for sure? Scientists have devised ingenious methods to probe the universe's shape and size. One approach involves studying the cosmic microwave background, CMB, radiation, the afterglow of the Big Bang. By analyzing the patterns in this ancient light, researchers can infer the universe's geometry. Current data suggests a flat universe, but even slight deviations could have profound implications for our understanding. In parallel, theoretical physicists are exploring the implications of string theory and quantum mechanics. These frameworks suggest that our universe might be part of a higher dimensional space, with unseen dimensions influencing its shape and behavior. Imagine our three-dimensional world as a sheet of paper floating in a multidimensional space. What lies beyond the paper could be an entirely different realm of existence. As we unravel these complex theories, one thing becomes clear: the horizon problem is more than a scientific puzzle. It's a window into the nature of reality, challenging us to reevaluate our assumptions about space, time, and existence. What if the edge of the universe is not a physical boundary but a conceptual one, a limit of human understanding rather than a literal frontier? This brings us to a crucial philosophical reflection. If the universe is infinite, or if there are countless other universes, where do we fit into this grand tapestry? Does our place in the cosmos diminish, or does it become more profound? These questions invite us to contemplate our role in the universe and the nature of consciousness itself. In the end, the horizon problem is a testament to the power of human curiosity. It reminds us that the pursuit of knowledge is a journey without end, one that transcends the boundaries of space and time. As you continue to explore the mysteries of the universe, remember that each question leads to new horizons, and every discovery opens the door to infinite possibilities. And so, the horizon problem remains an open question, a cosmic riddle waiting to be solved. Will future generations unlock its secrets, or will it forever elude our grasp? Only time will tell. But for now, the universe beckons, inviting us to explore its depths and ponder the mysteries that lie beyond the edge. Imagine standing at the very edge of everything you've ever known. The universe, vast, mysterious, and seemingly endless, stretches out before you. But what if beyond this grand expanse, there lies something even more incredible? Welcome to the multiverse hypothesis, a captivating theory suggesting that our universe might just be one of many floating in a cosmic sea. Picture this: infinite universes, each with its own set of rules, unique histories, and perhaps even versions of you. It's a mind-bending concept, isn't it? But why should you care about this theory right now? Because it challenges our most basic understanding of reality itself. The multiverse hypothesis isn't just an abstract idea. It's a potential solution to some of the universe's most perplexing questions. Take dark energy, for example, that mysterious force driving the universe's accelerated expansion. Or the cosmic microwave background, the faint afterglow of the Big Bang. These phenomena might find explanations through the lens of the multiverse. Let's start by diving into what the multiverse means. Imagine a boundless ocean, with each bubble representing a universe. Our universe is just one bubble, floating among countless others. Within each bubble, the laws of physics might differ. In some, gravity could be stronger, while in others, time might flow backward. The possibilities are endless. Now, think about the implications of such a theory. If multiple universes exist, then every possible outcome of every event could occur somewhere. This idea flips our understanding of probability on its head. And it opens up philosophical questions about fate, destiny, and free will. But before we get lost in the philosophical woods, let's look at how scientists have arrived at the multiverse hypothesis. It begins with the cosmic microwave background, a kind of cosmic fingerprint left over from the Big Bang. This radiation is surprisingly uniform across the sky, a fact that puzzled scientists for decades. The multiverse theory offers a tantalizing explanation. Perhaps our universe is just one of many, with each universe starting under slightly different conditions. Next, there's the strange case of dark energy. Discovered in the late 20th century, dark energy seems to be pushing galaxies apart at ever-increasing speeds. While this defies our conventional understanding of gravity, the multiverse hypothesis suggests that different universes might have different amounts of dark energy, making our universe's expansion just one of many possibilities. Now, what about the laws of physics? If the multiverse is real, it means the laws we take for granted might not be universal. In other universes, the speed of light could be different, or perhaps electrons don't exist at all. This raises a profound question. Why do our universe's laws allow life to exist? Some scientists propose that among countless universes, we happen to live in one where the conditions are just right for life, a concept known as the anthropic principle. But here's what most people don't know. The multiverse isn't just a theoretical playground. Scientists are actively searching for evidence. They're using the biggest telescopes and the most powerful particle colliders to find hints of other universes. For instance, a collision with another universe might leave an imprint in the cosmic microwave background, a subtle pattern that researchers are eagerly trying to identify. Let's take a closer look at inflation theory, a cornerstone of modern cosmology. Inflation suggests that the universe underwent a rapid expansion right after the Big Bang. Some versions of this theory propose that inflation never completely stopped, and instead, new universes are constantly being born, each with its own unique properties. Imagine the implications of this never-ending cosmic birthing process. It means that the universe, as vast as it already is, might just be a small part of an even grander tapestry. And within this tapestry, anything that can happen, does happen. Now, let's not get too carried away. The multiverse hypothesis, while fascinating, is still just that, a hypothesis. It hasn't been proven. But science thrives on exploration and questioning the boundaries of our understanding. The pursuit of the multiverse is a perfect example of this spirit. For you, as a curious explorer of the cosmos, the multiverse offers a new way of thinking about reality. It invites you to consider the possibilities beyond our universe's edge, to ponder what it means to exist in a realm of infinite potential. As we wrap up this section, let's leave with a thought-provoking question. If there are countless universes, each with its own version of reality, what does that mean for our understanding of existence? Does it make you feel small, or does it open your mind to the endless wonders of the cosmos? In the next section, we'll delve deeper into the tools and experiments scientists are using to explore these mind-bending ideas. How close are we to finding evidence of the multiverse? What challenges lie ahead in this cosmic quest? Stay tuned as we journey further into the unknown, where every answer leads to new questions and the boundaries of our knowledge are constantly pushed to new heights. Imagine standing on the precipice of all existence, gazing out into the unknown. Here, at the supposed edge of the universe, you might expect to find a boundary, a line that separates the known from the unknown. But what if there is no edge at all? What if the universe, so vast and incomprehensible, is finite yet unbounded? This is the essence of the finite universe theory, a fascinating proposal that challenges our very understanding of space and time. To begin unraveling this mystery, let's explore why some scientists believe the universe may be finite. It starts with the horizon problem, a conundrum that suggests the universe's uniformity is too perfect, too widespread to be explained by our current understanding. If the universe has an edge, why do distant parts look so similar despite being impossibly far apart, beyond the reach of light traveling since the beginning of time? A finite universe offers a solution. Space might curve back on itself, creating a closed system where every point is connected, no matter how far apart they seem. Imagine a balloon. As you inflate it, the surface expands, but it remains finite with no edges. You could travel endlessly along its surface without ever encountering a boundary. This analogy helps us visualize a finite universe. It's a cosmos where, despite its vastness, you could hypothetically travel in one direction and eventually return to your starting point, much like circumnavigating the Earth. But how does this notion affect our understanding of space and time? In a finite universe, the concept of distance transforms. Space isn't infinite, it's a closed loop. This changes how we perceive time as well, since time and space are intertwined in the fabric of the cosmos. The past and future may be more connected than we realize, potentially altering how we understand causality and the flow of time. Let's delve deeper into how scientists are exploring this idea. Instruments like the Cosmic Microwave Background Explorer have provided clues. This satellite mapped the faint afterglow of the Big Bang, revealing a remarkably uniform and isotropic universe. But here's what most people don't know. Subtle patterns, slight temperature fluctuations in this cosmic background radiation, hint at a curved, finite space. These patterns act like cosmic fingerprints, suggesting a universe that loops back on itself. Yet, the finite universe theory raises profound questions. If the universe is finite, what lies beyond its curvature? Is there an outside, or is our universe a self-contained bubble in a larger, incomprehensible reality? This is where the idea becomes truly mind-bending. The notion of an outside may be meaningless if the universe is self-contained. Instead, we might need to rethink our definitions of space and existence. Consider the implications for cosmology and physics. The laws of physics as we know them are based on an assumption of either infinite or bounded space. A finite, unbounded universe challenges these foundations, demanding new models and theories to describe reality. This could lead to groundbreaking discoveries, reshaping our understanding of everything from quantum mechanics to general relativity. It's a thrilling time for science, as researchers use cutting-edge technology to probe these cosmic mysteries. Projects like the Planck satellite continue to study the universe's background radiation, seeking new insights into its shape and structure. Meanwhile, advanced telescopes and particle colliders are pushing the boundaries of our knowledge, testing the limits of the finite universe theory. But perhaps the most profound aspect of this theory is its philosophical implications. It invites us to reconsider our place in the cosmos. Are we inhabitants of a closed loop, destined to repeat our existence in an endless cycle? Or does the finite universe hold secrets that could unlock new dimensions of understanding, revealing truths about our reality that we've only begun to imagine? As you ponder these questions, consider the universe not as a distant, cold expanse, but as a dynamic, living entity. It's a realm where every discovery leads to new questions, where the boundaries of our knowledge are constantly pushed further. And while we may never fully grasp what exists outside, or within, the edge of the universe, the journey of exploration promises to be as infinite as the cosmos itself. Imagine you're floating in the vast, silent expanse of space. Stars twinkle in the distance, galaxies swirl like cosmic whirlpools, and the universe stretches far beyond what the eye can see. But there's something else out here, a force so mysterious and elusive that it challenges everything we thought we knew about the cosmos. This is dark energy, a force responsible for driving the universe's accelerating expansion. But what is it, really? And how does it relate to the edge of the universe? When dark energy was first proposed, it was like a cosmic plot twist that no one saw coming. Back in the late 1990s, two separate teams of astronomers were studying distant supernovae. They expected to find that the universe's expansion was slowing down due to gravity. Instead, they discovered that the universe was not only expanding, but doing so at an ever-increasing rate. This was a shock to the scientific community, turning everything upside down. It was as if they'd discovered the universe had a secret agenda, a force propelling it outward at an accelerating pace. So, what exactly is dark energy? That's the million-dollar question, isn't it? In simple terms, dark energy is a form of energy that permeates all of space. It's invisible, and we can't directly detect it with our current instruments. Yet, it accounts for about 68% of the total energy in the observable universe. It's like an invisible hand orchestrating the cosmic symphony, influencing everything from the largest galaxy clusters to the tiniest particles. This mysterious force has profound implications for our understanding of the universe's evolution and fate. Imagine the universe as a grand balloon, with dark energy acting like an invisible breath, continuously inflating it. This means that galaxies are moving away from each other at increasing speeds. But what does this mean for the edge of the universe? Now, here's where things get really interesting. If the universe is expanding, what happens at its edge? Does it even have an edge? One theory suggests that the universe is finite but unbounded, like the surface of a balloon. If you travel in one direction long enough, you'll eventually end up back where you started. In this scenario, dark energy influences the rate of expansion but doesn't necessarily define a physical edge. Consider the idea of the observable universe, the part we can see and measure. Beyond this lies the unobservable universe. Here, dark energy's role becomes even more intriguing. It might be that the universe extends infinitely, with dark energy ensuring that we can never catch up with its accelerating expansion. It's like chasing a horizon that keeps moving further away no matter how fast you run. But here's what most people don't know. Dark energy could also be tied to the ultimate fate of the universe. Scientists speculate that if dark energy continues to dominate, it could lead to scenarios like the Big Freeze or the Big Rip. In the Big Freeze, the universe keeps expanding until galaxies drift apart, stars burn out, and all motion ceases. The Big Rip, on the other hand, suggests a more dramatic end where even atoms are torn apart by the relentless expansion. However, understanding dark energy is far from straightforward. It's a puzzle with missing pieces, and scientists are using various tools to try and fit them together. Telescopes, satellites, and particle colliders are all part of this cosmic detective work. Projects like the Dark Energy Survey and the Euclid mission aim to map the distribution of galaxies and measure cosmic expansion with unprecedented precision. To grasp dark energy's full impact, let's explore the implications of its discovery. Before dark energy entered the scene, the universe was thought to be governed mainly by gravity. This discovery flipped that notion, revealing a universe where gravity plays second fiddle to a mysterious force. It's akin to discovering that the puppet you've been watching is actually being controlled by an unseen hand, guiding its every move. The concept of dark energy also challenges our understanding of physics at a fundamental level. It raises questions about the nature of space and time, and whether our current theories, like Einstein's general relativity, fully capture the universe's complexities. Some scientists speculate that dark energy might be connected to quantum mechanics, existing as a sort of vacuum energy that fills space. But what if dark energy isn't a constant force? Some theories propose it might change over time, leading to different cosmic outcomes. This adds another layer of mystery to an already complex puzzle. It's like trying to solve a jigsaw puzzle where the pieces keep changing shape. As we delve deeper, it's clear that dark energy isn't just a scientific curiosity. It's a profound mystery that touches on some of the biggest questions in cosmology. What is the true nature of the universe? How did it begin, and how will it end? And what role does dark energy play in this grand cosmic narrative? These questions aren't just for scientists, they're for all of us. They invite us to ponder our place in the universe and what it means to exist in a cosmos that's constantly changing. So, when you look up at the night sky, remember that you're not just seeing stars and galaxies. You're witnessing a universe in motion, shaped by forces we barely understand. This ongoing quest to understand dark energy is more than just an academic pursuit. It's a journey into the unknown, a voyage that could redefine our understanding of everything from the smallest particles to the vastness of space. And as we explore these mysteries, we find ourselves on the edge of discovery, standing at the crossroads of science and wonder. As we wrap up this section, think about the implications of dark energy on the universe's edge. It challenges our perceptions and urges us to keep questioning, keep exploring. The answers might not come easily, but the journey itself is a testament to human curiosity and the enduring quest for knowledge. So, what do you think? Could dark energy hold the key to unlocking the universe's deepest secrets? Or is it just one piece of a much larger cosmic puzzle? Share your thoughts in the comments below, and let's continue this exploration together. After all, The universe is vast, and there's so much more to discover. Imagine a time so brief, it almost defies comprehension. A moment so fleeting, yet so monumental, it set the stage for everything we know. Welcome to the era of cosmic inflation. Picture the universe as a tightly coiled spring, suddenly released, unfurling with astonishing speed. In the blink of an eye, the universe expanded exponentially. But here's the kicker: this wasn't just any expansion. It was a burst that transformed an infinitesimal speck into a vast cosmos, embedding the seeds of galaxies, stars, and planets. The question is, what does this mean for the edge of the universe? To dive into cosmic inflation, let's rewind to its origins. The idea was born in the late 20th century, when physicists began to ponder the peculiarities of the universe. One of the most puzzling observations was the uniformity of the cosmic microwave background, CMB, radiation, the afterglow of the Big Bang. It seemed too smooth, too even, across vast stretches of space. How could regions of the universe, light years apart, have such similar temperatures if they were never in contact? This question was a thorn in the side of the Big Bang theory. Enter Alan Guth, a young physicist whose curiosity led him to propose a solution: cosmic inflation. Guth suggested that in the universe's infancy, a fraction of a second after the Big Bang, space itself expanded at a rate faster than the speed of light. This inflationary period, though brief, was enough to stretch and smooth out any initial irregularities, like spreading a layer of icing over a cake. Suddenly, the uniformity of the CMB made sense. But inflation did more than just explain the CMB. It laid the groundwork for understanding the large-scale structure of the universe, those vast cosmic webs of galaxies and voids. Imagine tiny quantum fluctuations, minute ripples in the fabric of space-time, existing in the early universe. Inflation stretched these fluctuations, amplifying them into the seeds from which galaxies would eventually grow. It's like watching the ripples in a pond transform into ocean waves. Here's the twist that keeps scientists on their toes. Cosmic inflation also hints at a universe without a definitive edge. If everything expanded from a single point, then the concept of an edge becomes murky. It's as if the universe, in its infancy, was like a balloon being blown up. The surface expands, but there is no edge to the surface itself, only more space. Now, you might wonder, how does this relate to what lies beyond the universe? If inflation smoothed out the universe to create the homogeneous cosmos we observe today, could it have also seeded realms beyond our visible horizon? Some scientists speculate that inflation could give rise to multiple, possibly infinite, pocket universes, each with its own laws of physics. This multiverse theory, while still highly speculative, suggests that our universe might be one of many, like bubbles in a cosmic foam. But let's not get ahead of ourselves. While cosmic inflation offers tantalizing possibilities, it also raises challenging questions. For instance, what triggered this explosive expansion? The mechanism behind inflation remains elusive, tied to hypothetical fields and particles yet to be discovered. And here's something even more mind-bending. If inflation could occur once, could it happen again? Could the universe undergo another rapid expansion, reshaping everything we know? As researchers continue to probe the universe, they're searching for signs of inflation in the cosmic microwave background. Tiny variations, known as B-mode polarization, could provide the smoking gun for inflation. It's a delicate task, like trying to hear a whisper in a noisy room. Instruments like the Planck satellite and the upcoming James Webb Space Telescope aim to capture these subtle signals, pushing the boundaries of our cosmic knowledge. And here comes the philosophical kicker. If our universe is just one of many, what does that mean for our place in the cosmos? Are we merely a small part of a grander, incomprehensible structure? Does the notion of an edge even matter in such a vast, interconnected multiverse? Cosmic inflation challenges us to rethink the universe's boundaries, urging us to consider a reality where edges are mere illusions, and possibilities stretch beyond our imagination. As you ponder these cosmic mysteries, remember that each new discovery, each new theory, brings us one step closer to understanding the universe's elusive edge, or lack thereof. Keep questioning, keep exploring, because in the vast expanse of space, there's always more to discover. Imagine you're standing on the edge of a vast ocean, staring out into the infinite horizon where the sky kisses the water. Now, imagine that ocean is the universe, and you're gazing into the unknown beyond its boundaries. What lies beyond the edge? Or is there even an edge at all? Some scientists propose a mind-bending idea, the quantum fluctuation theory. This concept suggests that space itself might be inherently edgeless and infinite. So, what exactly are quantum fluctuations? In the quantum world, particles and antiparticles spontaneously appear and vanish in a vacuum, a phenomenon known as quantum fluctuations. It's like a cosmic dance where particles pop in and out of existence, creating a dynamic and unpredictable landscape. But why should you care about these tiny fluctuations? Because they might hold the key to understanding our entire universe. You see, these fluctuations aren't just limited to subatomic particles. They could be the very fabric of our cosmos, suggesting that our universe is a bubbling, frothy sea of quantum potential, without a defined edge. Now, this might sound abstract, but let's break it down. Imagine blowing up a balloon. As it expands, the surface grows, but there's no edge, no boundary to be found. This is how some scientists envision our universe. It's constantly expanding, driven by these quantum fluctuations, but never reaching an end. It's a universe without borders, an endless tapestry woven by the threads of quantum events. And here's where it gets even more fascinating. These fluctuations might not only explain the expansive nature of space, but also the mysterious forces like dark energy. Dark energy is thought to be the driving force behind the accelerating expansion of the universe. And guess what? Quantum fluctuations could be the source of this enigmatic energy, a cosmic fuel that keeps our universe in perpetual motion. But that's not all. These quantum fluctuations might also shed light on the cosmic microwave background, the afterglow of the Big Bang. This faint radiation, permeating the universe, is a snapshot of the universe's infancy. By studying these fluctuations, scientists can piece together the story of the universe's birth and its evolution over billions of years. So, what does this mean for our understanding of space and time? If space is edgeless and infinite, then time might be just as fluid. Imagine time not as a straight line but as a river, meandering through the landscape of the universe, shaped by the ebbs and flows of quantum events. This challenges our traditional notions of time as a constant, linear progression. But here's a twist. If the universe is truly edgeless, does it mean there are infinite versions of reality, each differing slightly from the next? The idea of a multiverse emerges, where each quantum fluctuation spawns a new universe, a parallel reality. It's a tantalizing thought, isn't it? That somewhere out there, another version of you might be watching this video, pondering the same cosmic questions. Now, you might be wondering, how does all this affect you, right here, right now? Well, understanding these concepts could revolutionize technology and our grasp of the universe's deepest mysteries. Quantum mechanics already powers innovations like quantum computing, which promises to revolutionize how we process information. But it's not just about technology. It's about perspective. Realizing that we are part of an infinite, borderless universe can be profoundly humbling and awe-inspiring. It reminds us of our place in the cosmos, as tiny players in a grand, cosmic symphony. And as we journey deeper into the quantum world, we are faced with philosophical questions that challenge our understanding of reality itself. What is the nature of existence in a universe without edges? How do we define our place in such a vast, interconnected cosmos? These are the questions that keep scientists and philosophers alike pondering the mysteries of the universe. But here's what most people don't know. These questions aren't just theoretical. They're the driving force behind cutting-edge research. Scientists are using powerful telescopes and particle accelerators to probe the depths of space and the quantum realm, seeking answers to these fundamental questions. They're on a quest to capture the echoes of the Big Bang, to glimpse the fingerprints of quantum fluctuations in the fabric of the cosmos. And as they do, they're unraveling a tapestry of cosmic history, woven from the threads of time and space. Each discovery brings us closer to understanding the universe's grand design. And with each revelation, we are reminded of the infinite possibilities that lie beyond the edge. So, as you ponder the nature of an edgeless universe, consider this. Every question you ask, every mystery you explore, is part of a larger journey. A journey that doesn't just seek to understand the cosmos, but our place within it. And as we venture further into the unknown, we continue to push the boundaries of knowledge, forever curious, forever exploring. In the next section, we'll dive even deeper into these mysteries, exploring how scientists are testing these theories and what the future holds for our understanding of the universe. Stay tuned, because the journey into the unknown is just beginning. Imagine you're floating in the vastness of space. Stars stretch out in every direction, and the universe seems endless. But what if there's an edge? What lies beyond that boundary? if it even exists. This is where Einstein's theory of general relativity steps in, offering us a lens to peer into these cosmic mysteries. Let's dive into this theory. Picture space as a giant trampoline. When you place a heavy ball in the center, the surface bends around it. This is how Einstein described gravity, not as an invisible force, but as a warping of space and time by mass. This concept revolutionized our understanding of the universe. It suggested that massive objects like stars and planets curve the fabric of spacetime, influencing the motion of objects around them. Now, how does this relate to the edge of the universe? Well, general relativity doesn't just describe local gravity. It also offers insights into the universe's grand structure. According to Einstein, the universe is not static. It's dynamic, constantly expanding, with galaxies moving away from each other as if on a cosmic conveyor belt. But what does this mean for the universe's edge? Is there a boundary, or does spacetime curve back on itself, creating a universe without edges? Einstein's equations have been tested repeatedly, from the bending of light around the sun to the precise movements of planets. They've held up remarkably well. Yet, the implications of general relativity reach far beyond these tests. They touch on the universe's expansion and even the possibility of multiple universes, or a multiverse. Imagine standing at the edge of a vast forest. You can see trees stretching endlessly. But what if, beyond those trees, there were more forests, each with its own unique landscape? This is the multiverse hypothesis. It suggests that our universe might be one of countless others, each with its own laws of physics. General relativity, with its flexible view of spacetime, provides a framework where such a hypothesis could fit. But here's the twist. While general relativity shapes our understanding of the cosmos, it doesn't operate alone. Quantum mechanics, the theory governing the very small, often clashes with it. This clash becomes particularly significant when we consider the universe's edge. On one hand, general relativity suggests a smooth, continuous fabric of space. On the other, quantum mechanics introduces unpredictability and discrete chunks of spacetime. This brings us to a point of tension. If the universe has no edge, what prevents it from collapsing under its own gravity? Enter dark energy, a mysterious force causing the universe's accelerated expansion. It's as if a hidden hand is stretching the cosmic fabric faster than ever before. General relativity accommodates this expansion, but the true nature of dark energy remains shrouded in mystery. Let's take a moment to reflect on the role of Einstein's theory in this grand cosmic puzzle. It's like a map, guiding us through the universe's vastness. It helps us navigate the mysteries of black holes, the warping of time, and the potential for other universes. Yet, like any map, it has its limits. It can hint at what's beyond the horizon, but it can't provide all the answers. Here's a thought to ponder. If spacetime is curved, could traveling far enough bring you back to your starting point, like circumnavigating the globe? This notion challenges our linear view of space. It suggests that the universe might be finite yet unbounded, a concept both mind-bending and awe-inspiring. These ideas open doors to further exploration. They invite us to question and discover. Could future experiments shed light on these mysteries? Could new theories emerge, uniting the disparate worlds of relativity and quantum mechanics? To truly grasp the universe's edge, or lack thereof, we must continue probing the unknown. We must seek new ways to test Einstein's theory, to explore the fabric of spacetime with ever greater precision. And as we do, we might just uncover more about not only the universe's boundaries but also our own place within it. So, what's next on our journey? Perhaps a deeper dive into the clash between Einstein's elegant equations and the strange world of quantum mechanics. Or maybe an exploration of how dark energy fits into this cosmic tapestry. The universe is vast, and our quest to understand it is just beginning. Let's keep asking questions, seeking answers, and marveling at the wonders of the cosmos. Imagine you're gazing at a night sky filled with stars, each twinkling like tiny beacons of ancient light. It's vast, endless. Or is it? What if there was an edge to all this wonder? And what lies beyond? Right now, scientists around the world are on a mission to unravel this very mystery. They're using some of the most advanced technology ever created to peer deeper into the cosmos than ever before. But how exactly are they doing this? Let's start with the James Webb Space Telescope, a marvel of modern engineering. Think of it as the Hubble telescope's bigger, more advanced sibling. Launched to replace Hubble, the James Webb is like a time machine, allowing us to look back billions of years to see the universe as it was shortly after the Big Bang. Its primary mirror is over 21 feet across, giving it the ability to collect more light and see further into space. This telescope is designed to answer some of the toughest questions about our universe's origins and its ultimate fate. But here's the kicker: the universe is expanding, and the James Webb is helping us track that expansion. As it peers into the farthest reaches of space, it gathers data on how fast galaxies are moving away from us. This information is crucial because it helps scientists understand whether the universe will expand forever, slow down, or eventually collapse back on itself. And this ties directly into the question of what might lie beyond its edges. Now, let's shift our focus to another groundbreaking project, the Square Kilometre Array, or SKA for short. This isn't your average telescope. In fact, it's not just one telescope but a collection of thousands of antennas spread across continents. Together, they form the world's largest radio telescope. The SKA's mission is to map the universe in unprecedented detail, helping us understand phenomena like black holes, dark matter, and the mysterious force known as dark energy. Imagine trying to hear a whisper on a noisy street. That's what the SKA does. It listens for the faintest signals in the universe, signals that could hold secrets about the universe's structure and what might exist beyond it. By detecting radio waves from space, it can paint a picture of regions far beyond what we can see with optical telescopes. This is key because these radio waves can travel through cosmic dust that would otherwise obscure our view. However, these ambitious projects face significant challenges. For one, there's the sheer vastness of space. Even the most powerful telescopes have limits. They can't see past the cosmic microwave background, the afterglow of the Big Bang. It's like trying to look through a fogged-up window. Plus, the universe itself is constantly changing. Galaxies move, stars explode, and new ones are born. Keeping up with these changes is like trying to hit a moving target. Then there's the technological complexity. The James Webb Telescope, for instance, had to be folded up like origami to fit into a rocket and then unfold itself in space. Any failure could have spelled disaster. The SKA, meanwhile, has to process vast amounts of data, petabytes every day. That's more data than the entire internet handles. Designing systems to manage and interpret this data is a monumental task. Despite these hurdles, the potential discoveries are too tantalizing to resist. Imagine finding evidence of other universes or uncovering new laws of physics. What if we detect signals from intelligent life? These are not just questions for scientists, they touch on our very understanding of existence. As these projects continue, they're not just about looking outwards but also inwards. They force us to reconsider our place in the cosmos. Are we alone? Is there a boundary to our universe, or does it continue indefinitely? With every new discovery, we inch closer to answers. But here's where it gets even more intriguing. As we study the universe's edge, we are also learning more about ourselves. The quest to understand the cosmos is a journey that mirrors our own desire to comprehend life and its mysteries. It's a reminder that no matter how vast the universe may be, we are an integral part of it. As we wrap up this exploration of current research, you're probably left with more questions than answers. And that's the beauty of science. It thrives on curiosity. Each discovery opens up new avenues to explore. So, what will the James Webb Space Telescope and the SKA uncover next? Only time, and a lot of data, will tell. But one thing's for sure, the journey to the edge of the universe is far from over, and there's always more to explore. Feel free to leave your thoughts in the comments. What do you think lies beyond the edge of the universe? Are we close to a groundbreaking discovery? Let's keep the conversation going as we continue to explore the greatest mysteries of our universe together. Imagine this. You're standing at the edge of a vast ocean. Waves crash against the shore, stretching as far as the eye can see. Now, imagine that this ocean is the universe. But what if there's an edge to this ocean, a boundary that defines where it ends? And beyond that boundary, what lies there? The idea of the universe having an edge is more than just a scientific curiosity. It's a window into some of the most profound philosophical questions about reality and time. Let's dive into these questions headfirst. If the universe does have an edge, what does that mean for our understanding of reality? Consider this. What if our universe isn't the only one? The concept of a multiverse suggests that our universe could be just one of countless others, each with its own laws of physics, dimensions, and perhaps even versions of ourselves. It's a mind-bending thought, right? The multiverse theory challenges the notion that our reality is the only reality. It suggests a cosmic landscape where infinite possibilities exist. But here's where it gets really interesting. If there are multiple universes, what does that mean for our sense of self and our choices? Does free will exist in a multiverse, or are all possible outcomes happening simultaneously in different universes? Imagine every decision you make creating a new universe where each possibility is played out. It's like an endless choose-your-own-adventure story, except every path actually exists somewhere out there. This could mean that free will is an illusion, or perhaps it means we have more freedom than we ever imagined. Now, let's talk about time. In our everyday experience, time seems linear, a steady march forward. But if the universe has an edge, does time behave differently there? Some theories suggest that time might not even exist as we know it beyond the universe's boundary. It's possible that time is a construct of our universe, a way to make sense of change and sequence. If that's true, stepping beyond the universe might mean stepping outside of time itself. Imagine a place where past, present, and future all coexist. How would that change our understanding of history, memory, and destiny? This brings us to another profound question: morality. If there are countless versions of us making different choices, what does that say about right and wrong? Is morality universal, or does it shift with each reality? Philosophers have long debated whether moral truths are absolute or relative. The multiverse theory adds another layer to this debate, suggesting that moral decisions might not be about choosing the right path, but about navigating through a web of possibilities where every choice is played out. But let's pause for a moment. Imagine standing on a cliff, gazing at the stars, pondering these questions. It's both exhilarating and daunting. The idea that our universe might be one of many forces us to confront the vastness of existence and our place within it. It challenges us to rethink what it means to be human, to live a good life, and to make choices. Now, here's a thought to ponder. If reality is far more complex than we ever imagined, what does that mean for the human experience? Understanding the universe's edge isn't just an intellectual exercise. It's a journey into the heart of what it means to be conscious beings in a mysterious cosmos. It invites us to explore new ways of thinking about existence, purpose, and connection. As we delve deeper, let's consider the emotional impact. If the universe is so much more than we can perceive, how does that make you feel? Or inspired? Overwhelmed? Hopeful? These emotions are part of our exploration. They remind us that science and philosophy are not just about facts and theories, but about touching the core of our experience. And here's a final question to leave you with. If the universe's edge holds the key to understanding reality, time, and morality, what will you do with that knowledge? Will it change how you live your life, how you view others, or how you understand your place in the cosmos? The journey to the edge of the universe is not just about looking outward, but also about looking inward and discovering what it means to be truly alive. Imagine standing on a cliff, overlooking a seemingly endless ocean. You wonder what lies beyond the horizon, tantalizingly out of sight. This is what contemplating the edge of the universe feels like, a profound mystery that captures the imagination and defies the boundaries of our understanding. But what do we really know about the edge of the universe? And what are the implications of this cosmic enigma for our understanding of the universe and our place within it? First off, let's clarify something crucial. The universe doesn't have an edge in the traditional sense. When you think of an edge, you might picture a boundary you can cross. But in the vast expanse of the cosmos, things are a bit different. The universe is often described as infinite, continually expanding, with no clear boundary. Yet, this very notion is what makes the universe's edge a subject of intense debate among scientists and philosophers alike. You see, the universe's expansion is like a balloon inflating. Imagine dots on the surface of that balloon. As it inflates, the dots move away from each other. The universe works similarly, with galaxies drifting apart as space itself expands. But here's the kicker: if the universe is expanding, what is it expanding into? This is where the mystery deepens and where our understanding starts to stretch. Now, think about this. Some theories suggest that the universe is finite but unbounded, much like the surface of a sphere. You could travel in one direction and eventually end up back where you started, without ever encountering an edge. It's a mind-bending concept, isn't it? Yet, it's one way to grapple with the idea of an edge without a boundary. But here's what most people don't know. The enigma of the universe's edge isn't just about physical boundaries. It's a puzzle that challenges our very notions of space and time. It raises questions about the nature of reality and our place in it. For instance, if there is an edge, what does it mean for the fabric of spacetime itself? Could the laws of physics as we know them break down at such a boundary? These are the questions scientists are eager to explore. Further complicating this cosmic puzzle is dark energy. It's an invisible force pushing the universe to expand at an accelerating rate. Now, imagine this. What if the universe is not just expanding, but accelerating? This throws a wrench into the works, challenging our understanding of cosmic boundaries and the universe's ultimate fate. Could this acceleration mean that the universe will continue to stretch indefinitely? Or might it eventually rip apart in a dramatic event known as the Big Rip? And then there's the multiverse theory, a tantalizing idea suggesting our universe might be one of many, like bubbles in a cosmic foam. If true, what lies beyond our universe could be another universe, each with its own physical laws and realities. It's a concept that shifts the edge from a physical boundary to a boundary of understanding, a frontier of knowledge waiting to be explored. But let's pause here. This isn't just about scientific theories and cosmic phenomena. The implications of the universe's edge are deeply philosophical. They touch on who we are and our place in the cosmos. If the universe has an edge, does it redefine our understanding of existence? Does it change how we view our fleeting lives on this tiny blue planet? These are the kinds of questions that keep philosophers and scientists awake at night. Now, imagine if we could one day answer these questions. What if we could peek beyond the edge? It would be a profound moment, reshaping our understanding of the universe and our place within it. But until then, the edge remains a cosmic enigma, a boundary not just of space, but of knowledge and imagination. So, what's next? As we continue to gaze into the night sky, filled with more questions than answers, remember this: each question pushes us a little further, expanding not just our universe, but our capacity to wonder. And perhaps that's the greatest journey of all, exploring the infinite possibilities that lie beyond the horizon. But what if the universe isn't alone in its expansion? Stay tuned to explore how this cosmic mystery connects to the idea of parallel universes and what that could mean for us all. Imagine sitting under a vast, starry sky. The universe stretches out before you, a sparkling tapestry of cosmic wonders. But have you ever paused to wonder what's beyond this celestial display? In the quest to understand the universe, scientists are continually pushing the boundaries of knowledge, unraveling the mysteries of the cosmos one discovery at a time. But what lies beyond the edge of the universe remains one of the most tantalizing questions of all. Picture this: astronomers, gazing through powerful telescopes, glimpse galaxies billions of light years away. Their discoveries push the limits of human understanding, revealing a universe that's constantly expanding. Yet, with every new breakthrough, the question lingers: what's out there, beyond the farthest reaches of space? One of the most exciting aspects of modern astronomy is how rapidly our comprehension of the cosmos is expanding. Just think about the discovery of exoplanets, planets orbiting stars beyond our solar system. Not so long ago, these were mere speculation. Now, thanks to advanced telescopes like Kepler and TESS, thousands of exoplanets have been identified, each a potential world with its own mysteries. But here's where it gets even more intriguing. Despite all we've learned, the universe keeps throwing curveballs. The discovery of dark energy, for example, revealed that the universe is not just expanding, but accelerating in its expansion. This mysterious force, which makes up about 68% of the universe, is a reminder of how much we still don't know. It propels galaxies apart at ever-increasing speeds, leading scientists to wonder what this means for the ultimate fate of the cosmos. Let's dive deeper. Consider the cosmic microwave background radiation, the afterglow of the Big Bang. It's a relic from the universe's earliest moments, a snapshot of when everything began. By studying its minute fluctuations, scientists are piecing together the history of the universe. Yet, every answer seems to lead to more questions, especially as they attempt to map the universe's outer limits. Now, here's where your curiosity might really kick in. What if the universe isn't the only one? The multiverse theory suggests our universe might be just one of countless others, each with its own laws of physics. Imagine parallel universes, where every possibility is played out. It's a mind-bending idea, but one that physicists are seriously considering as they explore the nature of reality. But here's what most people don't know. Exploring beyond the universe's edge isn't just about figuring out what's out there. It's about understanding our place within it. The more we learn, the more we realize how interconnected everything is. Take quantum entanglement, for example, a phenomenon where particles remain linked, even across vast distances. It challenges our understanding of space and time, suggesting that the universe might be more interconnected than we ever imagined. As scientists continue their quest, new technologies are being developed to probe deeper into space. The James Webb Space Telescope, set to launch soon, promises to peer further back in time than ever before, potentially uncovering secrets of the early universe. But even with these advancements, the edge of the universe remains elusive, a boundary we might never cross, but one that continues to inspire awe and wonder. So, what's next in this cosmic journey? Scientists are not just looking outward, they're examining the very foundations of physics itself. By studying the smallest particles in powerful accelerators like the Large Hadron Collider, they hope to unlock new insights into the fundamental forces that govern everything. The aim is to bridge the gap between quantum mechanics and general relativity, two pillars of modern physics that currently don't see eye to eye. Imagine a future where these mysteries are solved, and we finally understand the true nature of the universe. It's an exciting prospect, but also a reminder of how much we still have to learn. The universe is vast, and its secrets are many. Each discovery brings us closer to understanding the cosmic puzzle, yet new pieces are always being added. In the end, the search for answers isn't just about scientific achievement. It's a journey of curiosity, wonder, and the human spirit, a reminder that we are part of something much larger than ourselves. As you look up at the night sky, remember, the universe is a vast, mysterious place. And while we may never know all its secrets, the quest to uncover them is a journey worth taking. What will we discover next? Only time will tell. Imagine you're holding a globe in your hand. You spin it, tracing your finger along the continents, the oceans, the poles. Now, imagine that globe is the universe, a vast, seemingly endless expanse. But here's where it gets intriguing. Every edge you encounter on this globe, every boundary, raises a question. What lies beyond? In our universe, the concept of an edge is not just physical, it's a gateway to deeper understanding. The universe's edge is just one facet of its immense and intricate nature. It's like trying to comprehend a grand symphony by focusing on a single note. Each note matters, but the entire composition is what truly captivates. So, why should you care about this one aspect, the edge? Because in understanding what lies at the boundaries, you gain insights into the universe as a whole. Think of the universe as a colossal jigsaw puzzle. Each piece represents a cosmic phenomenon: galaxies, black holes, dark matter. The edge, then, isn't just the final piece, it's the frame that holds the puzzle together. It challenges us to rethink our place within this cosmic tapestry. But what does this edge signify? It's a question that has puzzled scientists for years. The universe is a complex system, filled with wonders waiting to be explored. When you consider the universe's edge, it beckons you to delve deeper into its mysteries. It isn't just about what's beyond, it's about redefining the known boundaries of space and time. At the edge, the cosmos offers a tapestry where every thread is interwoven with the unknown. It's like standing at the shore of an ocean, aware that beneath the waves, a hidden world thrives. Scientists are eager to map these cosmic shores, uncovering phenomena that defy our current understanding of physics. Now, let's put this into perspective. Imagine the universe as a massive, expanding balloon. Every point on its surface moves away from every other point. The edges aren't fixed, they're dynamic, constantly evolving. And here's the twist: unlike a balloon, the universe doesn't expand into anything. It's not expanding into space, space itself is expanding. This brings us to a profound realization. The universe's edge is not an end but a beginning of understanding how the fabric of space-time stretches, bends, and warps. It challenges the notion of infinity, offering a paradox. How can something boundless have an edge? And this is where the significance lies. By contemplating the universe's edge, you're not just peering into the cosmos. You're exploring the limits of human knowledge. You're engaging with ideas that push the boundaries of what we know about existence itself. So, what does this mean for our understanding of the cosmos? The universe's edge is a reminder that every answer leads to a new question. It's a call to embrace curiosity, to question, to seek. It shows us that even as we stand on the precipice of discovery, the horizon continues to stretch beyond our sight. But here's the catch. What if the edge is more than just a boundary? What if it's a portal to multiverse, each with its own laws of physics? This speculation fuels a deeper inquiry, suggesting that the universe we see is just a sliver of an even greater reality. As you ponder these possibilities, consider this. Every great discovery began with a question and a willingness to explore what lies beyond. In the grand scale of the cosmos, the universe's edge is a testament to our insatiable quest for knowledge. It's a challenge to our imagination, urging us to look beyond what is visible and seek the invisible truths that shape our reality. So, as we journey further into this mystery, remember, the edge is not just a limit, it's an invitation to explore the endless possibilities of the cosmos. Imagine standing at the edge of a vast ocean. The horizon stretches endlessly, and you can't help but wonder what's beyond that line where the sea kisses the sky. Now, replace the ocean with the universe. What lies beyond its edge? This mystery is not just a question of distance or space. It dives deep into the essence of our existence and our place in the cosmos. Let's start by considering the concept of the universe's edge. It's a notion that teases the imagination. If the universe has an edge, what does that mean for us, nestled within its limitless expanse? Are we just a small part of something much grander, or is there more to this cosmic puzzle? One fascinating idea is the multiverse theory, which suggests that our universe might be just one of many. Think of it like bubbles in a cosmic foam, each bubble representing a different universe. If this is true, our reality could be just one of countless others, each with its own laws of physics and possibilities. It's a mind-bending thought, isn't it? The multiverse challenges our understanding of existence itself, hinting that there might be infinite versions of reality out there. But what does this mean for us, for you and me, living our everyday lives? Well, contemplating the multiverse can shift our perspective on everything. It suggests that the universe isn't just a backdrop to our existence but a dynamic, complex entity that we are intimately a part of. This idea can feel both humbling and empowering. It provokes us to think about the significance of our actions and the unique role we play in this cosmic drama. Now, let's delve deeper. If our universe is just one of many, what's the purpose of it all? Does the universe have a reason, or is it simply a cosmic accident? These questions have puzzled philosophers and scientists alike for centuries. Some argue that the purpose of the universe is to create conditions for life, specifically intelligent life, which includes us. Others propose that the universe is a grand experiment, or even a simulation. These are intriguing possibilities that invite us to question the nature of reality itself. Consider this. If we are part of a multiverse, it might mean that every decision we make creates a new path, a new universe. Imagine the implications, an infinite web of possibilities unfolding with every choice. This perspective can inspire us to view our decisions with greater responsibility and wonder. But let's not get ahead of ourselves. The multiverse theory, while captivating, is still just a theory. It remains one of many hypotheses that scientists use to explain the mysteries of the universe. The beauty of science lies in its continuous quest for truth, for answers that push the boundaries of our understanding. So, what does all of this mean for our understanding of human existence? It challenges us to think bigger, to look beyond the confines of our everyday experiences. It encourages us to explore the cosmos, not just as scientists or philosophers, but as curious beings eager to understand our place in the universe. As we ponder these questions, it's important to remember that the quest for knowledge is an ongoing journey. Each new discovery opens up more questions, more mysteries to unravel. This is what makes the universe so endlessly fascinating. It's a reminder that we are part of something much larger, a cosmic narrative that is still being written. In the end, the mystery of what exists outside the universe's edge is a reflection of our own desire to understand, to seek meaning in the vast tapestry of existence. It's a journey that invites us all to look up at the stars and wonder, not just about what lies beyond, but about the role we play within this magnificent universe. As you continue this exploration, remember that every question leads to new possibilities, and each possibility is a step closer to understanding the grand cosmic puzzle. As you ponder the mystery of the universe's edge, you're not alone. This question has captivated minds for centuries. It's a profound enigma that stretches our understanding and fuels the curiosity of both scientists and philosophers alike. Imagine standing on the precipice of an unexplored frontier. The cosmos, vast and silent, calls out. What awaits us beyond the universe's boundary? Is there anything there at all? Or is it a void, an expanse of nothingness that defies comprehension? This mystery isn't just a philosophical puzzle, it's a scientific challenge that demands exploration. As we peer deeper into the cosmos with advanced telescopes and spacecraft, every new discovery adds a layer to our understanding of the universe. Yet with each answer, more questions arise. It's this dance of discovery and mystery that reminds us of our place within the cosmic tapestry. We are but a speck, a fleeting moment in the grand scheme of things. And yet, our desire to know more is boundless. So, where do we go from here? What are the next steps in our journey to understand what lies beyond the universe's edge? It starts with pushing the boundaries of our current technology. The James Webb Space Telescope, for instance, is designed to look further into the universe's past than ever before. By observing the faintest galaxies and the first stars that formed after the Big Bang, we hope to glean insights into the universe's infancy and its possible edges. But here's a twist. What most people don't know is that some scientists propose the universe might not have an edge at all. Instead, it could be infinite, curving back on itself in a way that's difficult to visualize. Picture an ant crawling on a balloon. To the ant, the surface seems endless, but we know it's finite. Could our universe be a higher dimensional version of this balloon? These are the kinds of mind-bending ideas physicists are exploring. Another avenue of exploration is the study of dark energy, the mysterious force driving the universe's accelerated expansion. Understanding dark energy could reveal whether the universe will continue expanding forever or collapse back on itself in a big crunch. Each possibility carries implications for what lies beyond, or doesn't, at the universe's edge. Yet, the journey doesn't end with scientific exploration. It also involves a philosophical reflection on what it means to seek the edges of existence. Why are we driven to understand the universe? Is it a quest for knowledge, a desire for connection, or something deeper? As you contemplate these questions, you become part of a larger human narrative, a collective striving to understand our place in the cosmos. Let's not forget the role of collaboration in this cosmic quest. Scientists from around the globe work together, sharing data and insights, driven by a common goal. This spirit of cooperation is essential, for the universe doesn't yield its secrets easily. It requires persistence, creativity, and a willingness to embrace the unknown. In this quest, small steps lead to great leaps. Each new discovery, whether a speck of dust from a distant galaxy or a faint echo of cosmic background radiation, brings us closer to understanding the universe's grand design. The edge of the universe may remain elusive, but the journey to find it enriches our understanding of everything else. So, as you ponder the cosmos, remember that every question you ask, every curiosity you pursue, contributes to humanity's ever-expanding knowledge. The universe, vast and mysterious, remains an open frontier. And as we continue to explore, who knows what wonders await us beyond the next horizon? The edge of the universe is not just a boundary but a gateway to endless possibilities. What lies beyond? That's a question you can help answer.